Hello friends. So this is going to be a video covering what we went over in class Tuesday, October 2nd, and what we're going to go over class on Tuesday, October 3rd. Just in case you were gone, some of it's a little hard when you're just drawing it on the paper to kind of see what's happening if you're not using the algebra tiles as well. So let's just jump right in. Before we do the warm-up, we're going to go over what a term is. A term is part of an expression, a mathematical expression or equation. It can be a constant number, so just a number without a variable, like 5, -3, 1/2, -0.27, anything like that. It's just a number. It can be any type of number. A term can also be a variable, like x, y, r, s, t, q, p, whatever letter you wish. Then the last thing it can be is a variable times a number, like 2x, 5x, 3x. We should be a little bit familiar with those, things like variables and that. Maybe just didn't have a name for them before. So our warm-up says, circle all like terms in the following expressions. Like terms are terms that have something in common. They have the same variable. So let's look. Which ones have the same variable? Let me grab some highlighters. There we go. So, number 1, we have x minus 3 plus y plus 7x plus 11. The first one that sticks out to me is that I have x and plus 7x. So those are like terms because they both have the same variable. Their coefficient, or the number in front of them, is different, but that's totally okay. They have the same variable. Now, at first glance, we might not think that there are any other like terms in this expression, but there are. Minus 3 and positive 11, those are like terms, which doesn't super fall under our description of like terms, that thinking they have the same variable. If you want to know why, like a further proof, you can ask, that's fine, I'll tell you. But I'm just going to tell you the short way to know is that if it's a constant, its like term is also going to be a constant. So if I have a number without a variable and another number without a variable, those are going to be like terms. So all I'm doing is circling them. Or I'm going to highlight them in different colors. So 20z plus a plus 9 minus 30z minus 11a. I'm going to look for ones that have a variable in common. So I see 20z and minus 30z. I'm going to keep that minus with the 30z. It will come in handy later, but you need to realize that the minus goes with the 30. Then I'm looking, a, yes, there's another one that has a variable of a. So plus a and minus 11a. So let's look at number 3. That'll be the last one we do together, then you'll have to do them on your own. C minus x plus m plus x minus m. So I'm just going to start at the beginning and go left to right, see if there's any that have in common. So I have a c, I look. Alright, there's no other ones that have a c as the variable, so I know that doesn't have a like term. I have minus x. Oh, there's another one that has x. I'm going to keep the minus with the x, and then plus x. Those are like terms. Then I have m and a minus m. Those are the same letter, the same variable. They are like terms as well. So go ahead, pause the video, try 4, 5, and 6 on your own. See if you can not group them. See if you can figure out which ones are like terms in the following expressions. Alright, I hope you pause the video and try them on their own. It's really important that you do try examples on your own. So, I went ahead and answered them. Oops, sorry. There we go. I went ahead and answered them. Go ahead and check. If you got one wrong and you're not sure why, just raise your hand. I'll come help you. Or if you're watching this at home, ask me in class when you get back. So this part says rearrange the terms and expressions. We're going to skip that part for now, and we're going to jump down here. We're going to use algebra tiles first. So if you haven't been here, or maybe you didn't know, these little dudes are called algebra tiles. I have some big squares, some small squares, some rectangles. These are called algebra tiles. These big squares, the blue and red ones, they represent x squared. We're not going to be dealing with that right now. We're going to worry about that later, so we can just go ahead and put those away. So I have these manipulatives down here. Let me get some more. All right, so just to recap in case you weren't here, the square represents a constant of 1. The yellow is positive, so positive 1. The red is negative, negative 1. They're kind of like those circle counters we were using a few weeks ago. These rectangles represent x. They represent any variable. The variable we're going to choose is x. The red side is negative, the green side is positive. So right here I have 1x and then negative 1x. If I had 2, this would show me 2x or negative 2x. They kind of just work like those circle color counters that we were using. So use algebra tiles to represent and simplify the following expressions. For now, all we're going to do is represent them. We're not going to simplify. We're going to represent, regroup, and then rewrite. But we're not going to simplify. We're not going to solve. So I have x plus 1 plus 2x. So I start with my manipulatives. I grab a rectangle, and it's green, to represent positive 1x. Then I add 1, so I need one that is a little square, represents a constant, plus 1, then plus 2x. So I'm adding 2x. So it should look something like this. If you have them horizontally, that's fine. If you have them this way, that's fine, as long as you have 1x plus 1 plus 2x somehow. I'm going to shift them back to how I like them. It makes my brain happier when they look like that. So I've placed this on my table. I'm going to go back in my notes and I'm going to draw what that looks like so that when I'm at home and studying so hard, I know what I was doing. So I draw a rectangle. Now if you don't have different colors, that's fine. You can just draw a plus sign inside of the rectangle so that you know it means positive x. And I'm going to go underneath that and label it as x. Then I have one square. I'm not going to use yellow, it doesn't show up well, but I draw a square with a plus sign in it to show positive 1. So I'm going to show that I added 1. Then once again, I'm going to draw 2 green rectangles with plus signs in them to show positive 2x. I'm just drawing over here what my manipulatives look like. I'm going to write plus 2x. So I did that. I represented the initial expression. So now I'm going to rearrange and group like terms. So x and x, those are like terms. How I can kind of think about this is these are the same shape and the same size. They're both rectangles. They're both the same size. One's not bigger than the other. So they're alike. Even if they're red, they're not the same thing, but they are alike. A square and a rectangle, these are not alike. They're very much not the same size. So I'm going to group rectangles with rectangles, squares with squares. I'll get rid of these extra ones. So I'm just going to rearrange. I'm going to move this over. I'm going to move these two rectangles, my 2x over, so it's closer to my 1x, so that they're kind of ordered. So all I did was rearrange. Now I'm going to write that on my paper. I'm going to draw an arrow and write that I rearranged and draw what this looks like over here. I have 1x with a plus sign in it. I'm going to label it x because that's what it is. Plus, then I have 2x. So I'm going to draw that. So I'm going to take those away because I've already drawn them, and I'm left with a positive 1. So I draw a square with a plus sign in it. So all I've done was I took my initial expression of x plus 1 plus 2x, and I rearranged it to be x plus 2x plus 1. Notice I didn't get rid of anything. All I did was I moved them around to be in a different order. So I represented the initial expression, I rearranged it so that like terms were grouped, then I rewrote the expression. So I did all the steps that I should right now. We're going to hold off on simplifying for a tiny bit. Alright, so number, or letter B I guess, is 3 minus 2x plus 4. So I need positive 3, so I need 3 ones. So 1, 2, 3. Oops. They should all be positive. Mine flipped over a little bit. There we go. Minus 2x. To show minus 2x, they need to be negative 2x. They need to be red because if we throw it back a couple of weeks, we use keep, change, change. We know that 3 minus 2x is the same as 3 plus negative 2x plus 4. So subtracting is the same as adding a negative. I know that's kind of confusing. It's not the most comfortable terminology, but that's what it is. So 3 plus negative 2x, or you can think of it about it as 3 minus 2x plus 4. So I need to grab 4 positive ones. So it should look like that. Then all I'm going to do is go back over here and draw what it looks like. So I have 3 squares that are all positive. So I drew 3 squares with plus signs in them. I'm going to label it 3. Then I added negative 2x. So I'm going to draw a rectangle with a minus sign in it to show negative x, and I have 2 of them. So plus negative 2x. Then I have 4 squares that are positive, so I draw a square with a plus sign. 2, 3, 4. So represent the initial expression. I did that. Then I rearrange. Oops. So that all my like terms are grouped. So I'm going to put squares with squares, rectangles with rectangles. So I'm going to move these away real quick. Move these over. Put these over here. So squares are next to squares, rectangles are next to rectangles. So I'm going to draw how I rearranged it. 1, 2, 3. 3 positive squares. Kind of in my way, gonna move them up a little bit. Then I had 4 of the same thing. 2, 3, 4 positive squares to represent positive 4. I'm gonna label those. So this is 3 plus 4. Then I added a negative 2x. So I'm going to write that as plus negative 2x. So I regrouped and then I rewrote down here. Go ahead, pause the video, and try C and D on your own. All right, so you should have done C and D on your own. Do it with me real quick if you didn't, or if you did, check your work, see if it was right. So I have x plus 5 plus 2x plus 3. So I start with x plus 5 ones, 1, 2, 3, 4, 5, plus 2x plus, oh, that's one's red, there we go, plus 3, 1, 2, 3. I'm going to go ahead and draw that real quick. X plus 5 plus 2x plus 3. I'm going to write them down here. Then I'm going to rearrange so that my x terms are next to my x terms, my 1s are with my 1s. You can also think about rearranging by shape. Oops. I like to make sure that they're all lined up still. There we go. So all I did was rearrange, and I'm just going to draw what that looks like. So 1x, and label it, then plus 2x, label it, then add plus 5, 1, 2, 3, 4, 5, and then I had 3, 1, 2, 3. Now, real quick, if we notice, I originally had parentheses around these, x plus 5 plus the quantity 2x plus 3. I can now put the parentheses back here, and I have x plus 2x plus 5 plus 3. That way, if I want to use my order of operations, I can solve that. That'll come in handy in a little bit. So down here, I have 3x minus 2, so I have 2 red ones, plus x plus 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm just going to draw what that looks like down here. One, 2, 3. I have minus 2, so it's going to be red. 1. Make sure they have minus signs in them. So this is 3x minus 2 plus, add 1x plus 8. I rearrange so that x's are by x's, ones are by ones, or rectangles and squares if you want to do it by shape. And what I ended up having was 3x plus 1x, oops, come back, plus, I'm going to do the 8 first. I'm going to rearrange it this way. Oops, that's the red one. Plus 1, 4, 5, 8. Then minus 2. This is plus 8 minus 2. Put parentheses around it, please. So, let's go back up here. We'll bring it down a little bit so you can see it better. And now we can rearrange these. How I'm going to rearrange these without using my algebra tiles is first find all the like terms, like we were doing up here in the warm-up. So I have x plus 7x minus 3 plus 11. Those are like terms. Y is by itself. So I'm just going to rearrange. Here we go. So I'm going to put 7x next to positive 1x. So I have x plus 7x. I'm going to leave y by itself, plus y. Then I'm going to put plus 11 by minus 3. So I write minus 3 plus 11. All I'm doing is rearranging. I'm not simplifying. I'm not solving anything. I'm just rearranging right now. Same thing with number 5. I'm going to find like terms. I have 7a and a plus a. 12 is a constant, doesn't have any other constants. There's no other 4b. I'm going to start alphabetically. So 7a plus a. I'm then going to move on to 4b because that comes next in the alphabet, plus 4b. Then I'm going to write my constant last, plus 12. So I'm going to do anything with a variable first, write them alphabetically, and then my constant last. So I have minus 8n plus n. Actually, pause the video, try 6 and 7 on your own, then come back and check your work. All right, so to check your work, I have minus 8n and plus n. I have minus m and plus 6m. 8 is a constant, but it's by itself. There's no other constants. It doesn't have a like term. So I'm going to write plus n next to minus 8n. I have negative 8n plus n. I didn't do this one alphabetically. That's okay. It doesn't have to be. Then I'm going to put 6n by minus m, as in moose. So minus m plus 6m. Then I have my constant. It doesn't have any other like terms, so it's by itself. All I'm doing is rearranging the expressions. let's look at number 7. So I'm going to start at the beginning, negative w. Well, there's no other w's in my expression, so it's fine the way it is. There's no other x's, there's no other y's. So I don't need to do anything to my expression. It is arranged correctly. I'm just going to rewrite it so that I know I did it. All right. So now that we're more comfortable with rearranging expressions, let's come back down over here and we're going to learn how to simplify expressions. So my first one, x plus 1 plus 2x. I rearranged it and I got x plus 2x plus 1. Oops. There we go. X plus 2x plus 1. To simplify, I'm just going to count how many of each like term I have. How many total x's do you have? 1, 2, 3. I have 3 x's, so that's 3x. Then I'm going to count how many squares I have, how many ones. I have 1, and it's positive, so plus 1. We just added the expression. We just simplified the expression. So x plus 1 plus 2x, when you group like terms, x plus 2x plus 1, that's what we're doing. We're grouping like terms. Then we combined like terms. We said, how many of each of the like terms are there? So with our like terms that are x plus 2x, there are 3 total x's there. So 3x, and there's 1 square, which represents 1, so plus 1. Same thing over here. I started with 3 minus 2x plus 4. I rearranged, got 3 plus 4 plus negative 2x. So 3 plus 4 plus negative 2x. I'm going to combine like terms, which just means to add or subtract like terms. All of my squares, those are one type of like term. There's 1, 2, 3, 4, 5, 6, 7 squares. So it tells me that this is 7. Then I have negative 1, negative 2x, because these represent x. So I'm going to say plus negative 2x. I just simplified it by combining like terms, is what that's called. Try C and D on your own, so go ahead and pause the video. All right, so let's check your work after you pause the video. I have x plus 5 plus the quantity 2x plus 3. So x plus 5 plus 2x plus 3, I rearranged it to get x plus 2x plus the quantity 5 plus 3. I can write the parentheses around here because of the associative property. So how many total x's are there? If I set it up again, I have x plus 2x, 1, 2, 3 total x's, so 3x. All right, then I have 5. Oops, carried one over. There we go. Then I have 5 plus 3. How many total ones, how many total squares do I have? 1, 2, 3, 4, 5, 6, 7, 8. I have 8, so it's going to say plus 8. So I'm going to try this one by just counting what I drew instead of setting them all up. Just kidding, let's set it up. It's not that much work. So I have 3x plus x plus 8 minus 2. So I'm going to write it down here because I'm running out of space. How many total x's do I have? I'm going to combine like terms. Here's a like term. Here's a like term. I'm going to combine them. I have 1, 2, 3, 4x plus, and I have 8 minus 2 or 8 plus negative 2. This works the same way. Remember when we were making 0 pairs with the 2 color counters or additive inverses? If I have positive 1 and negative 1, those add together to make 0, so I can match a positive and a negative, and they go away. Same thing, a positive and a negative, they go away. I'm left with 1, 2, 3, 4, 5, 6 ones. So 4x plus 6 is what I finally arrive at. Go ahead, let's flip to the back page. And we're going to do the top section. All right, combining like terms. You can combine like terms by adding their numerical coefficients. That's what we saw over here. We saw 3x plus x. This is 3x plus 1x equals 4x. 3 plus 1 is 4. So same thing over here. We're just going to add the number in front of them. Remember that if it's just a variable by itself, like x, that's saying 1x. So 8x plus 4x, I just say, what's 8 plus 4? 12. So it's 12x. You're going to need to remember your addition and subtraction rules. They'll come very in handy right now. You might have to look them up, and that's totally okay. So, negative 3c plus 7c. Remembering my rules, this is going to be 4c. If you need to use the song, let's do that with number 10. All right, so negative 8x plus negative 15x. If we remember our song, same sign, we add the number, different sign, subtract them, take the sign of the bigger number. So, same sign or different? Well, they're both negative, so they're the same sign, so we're going to add them together. I'm going to do 8 plus 15 is 23x. Then I take the sign of the bigger absolute value. The absolute value of negative 8 is 8. The absolute value of negative 15 is 15. This is going to be the bigger absolute value. It's negative, so it's negative 23x. Go ahead, pause the video, try 12 through 14 on your own. All right, so if you did them on your own, let's check them real quick. So I just add or subtract their coefficients, the number in front. 20 minus 12 is 8, so I get 8y. Negative 4r minus 8r. If you need to use keep, change, change to make this negative 4r plus negative 8r, that's fine. We use our song if you need to, or maybe you can just do it in your head. Whatever your method is, that's fine. We get negative 12r. Then again, I just subtract 21 from 23. I'm adding or subtracting their coefficients. I get 2a. So that's it.